Hello my dear students, this is Rima. I hope you're doing great, and in today's video we will be studying the graphical derivation of the equations of motion. In our previous sessions we have studied how to derive the equations of motion. There are three equations of motion and how to derive them. Okay, and here in this session we will be studying how to derive them graphically. And okay, so those who have not subscribed to my videos, please just go and subscribe, and also don't forget to click the bell icon to get notified of my future videos. Okay, so let's get started. And now we are going to derive the equations of motion graphically. Okay, so we need a graph. See, so this is, I have drawn a graph. That is a velocity time graph, VT graph I have drawn. Okay, and for example, this will be my velocity. This will be my time. That is on the x-axis, and velocity will be on my y-axis. Okay, so my object has moved. Okay, this will be my origin. Okay, that my object has moved from initial velocity, that is u, initial velocity u, to a final velocity. So see, this will be, take this as AB. Okay, take this as AB. So my object has moved from initial velocity u to final velocity v. So final velocity will be here, right? So this will be my v. Okay, this straight line shows what? Uniform acceleration. Okay, so we have studied that also, no? So we will, from B, we will draw a line which is parallel to the y-axis and which is touching on the x-axis, and here also from B we will draw a line which is parallel to the x-axis, and we are going to name this A, B, C, D, O is here, and this will be E. Okay, similarly from here, what here? Okay, from A I have drawn a line joining this line, and that is joining in C. Okay, so first this is our VT graph and this is our graph. Okay, showing uniform acceleration, accelerating from u velocity to final velocity v. So what is OA is what? OA is what? OA is u, right? So this is u and OA is u. And now what will be OE? So OE will be what? V. This will be v, right? So if this is u and this is parallel, no? So what will be CD? CD will also be u, right? Now what will be? So now CD is u. So what will be my BD? BD will be equal to this thing, no? So this thing is V. So this will also be V. BD will also be V. BD will be equal to OE, right? So now we have to prove whether V is equal to U plus AT with our graph. Okay. So previous case also, first equation of motion we have derived from acceleration. So here also, what is acceleration? Acceleration is rate of change in velocity. Rate of change in velocity by time. Right, change in velocity by time. So here, change in velocity. What is change in velocity? My velocity initially was u. U to v it has changed. From u to v it has changed, right? So what is my change in velocity? Change in velocity will be BC, right? BC. So my change in velocity is BC divided by, and what is time here? Time, okay, time will take it as T. Okay, this will be T. So this will also be T, and this will also be T. So the acceleration is rate of change of velocity. U, from U it changed to V. So what will be my change? This will be my change. So BC by T. So now what is BC? BC is what? BD minus CD. So BD minus CD will give me BC, right? So BC by time. So this will be BD minus CD by time. What is BD? BD is V and CD is U. So it is V minus U by time. So A is equal to V minus U by T. So V minus U is equal to AT. V is equal to U plus AT. And this is my first equation of motion. And we have derived graphically, right? So first we have drawn the VT graph. That is my body accelerated from velocity U to velocity V. So here this will be V and this will be U. Similarly, this will be U and this will be V. So what is the change in velocity? Change in velocity will be BC. That is BC divided by time gives us the acceleration. So BC is what? V minus U. That is BD minus CD. Hence we have derived the first equation of motion. So next we will be deriving the second equation of motion, that is S is equal to ut plus half et square using graphical method. Okay. So again I have drawn the graph here. So this is my VT graph, velocity and time, and my object has accelerated from U velocity to V. So this is V and this is U. From U the body has been accelerated uniformly to V. Okay, and this hence we got the slope here. Okay, and now here we have to find the displacement. So what is displacement? Displacement is, we studied earlier, right, will be the area under the slope. So this is my, so AB is my slope. So area under this slope, if we find, we get the displacement. So again we have marked A, B, C, D, O and E. Okay, and you know AO is U and EO is V. Similarly BD will be V and CD will be U, and therefore you know BC will be V minus U, right? So displacement is area under the slope. So I'll write it here. Displacement, S equal to area under slope, which is what? Area of the trapezium, right? Area of the trapezium AOBD, right? AOBD. So area of trapezium AOBD. And what is the trapezium now? Area of this triangle plus this rectangle, no? So area of triangle we can call ABC. ABC plus area of rectangle, how much it is? ACDO. ACDO. So area of triangle is what? Half BH, no? Plus area of rectangle is L into B, length into breadth. So what is B and H now? Half. B is what? For the triangle, B is what? B is what? AC. B is, AC into height is what? BC. BC plus L, length of the rectangle is OD. OD into breadth is what? CD. DC, I'll write. Okay. So half, what is AC? AC is T. So here it is T, so this will also be T. AC is T into BC is what? BC is V minus U. BC, V minus U. V minus U plus what is OD? OD is T. T into DC is what? U. So, we have got S is equal to half T into V minus U plus T into U. And you know that in this second equation of motion, we don't have the final velocity. Only A is here. So, we have to replace V, so that V is not there and only A will be there. So, how much is acceleration? What is acceleration? A is equal to V minus U by T. So, AT is equal to V minus U, and therefore, what is V? V is equal to U plus AT, right? So, that will substitute here in this V. So, S equal to half T into U plus AT minus U plus UT. So, it will be half T into U and U will be cancelled. So, it will be into AT plus UT, which is equal to UT plus half AT square. So, S is equal to UT plus half AT square, which is our second equation of motion, and we have derived it graphically. So, area under the slope will be what? Our displacement. So, displacement is equal to area of triangle ABC plus area of triangle ACDO. So, half BH plus LB, and we have substituted all these terms. We got this, and we don't need this V here because second equation of motion, final velocity won't be there. So, we have substituted acceleration instead of this. Acceleration we found it as V is U is equal to FT. So, V U plus AT. So, that we have substituted instead of V, and we got the second equation of motion using the graphical method. Okay, now we will be deriving our third equation of motion graphically. Okay, third equation of motion, what it is? 2A is equal to V square minus U square. So, we have to derive this using our graph. Okay, now also here also we will take displacement. So, what is the displacement? Displacement, how to find using VT graph will be the area under the slope, right? So, this area again we have to find. So, there how did we find the area? This triangle plus this rectangle, right? So, here we will find the area of this trapezium directly, and then we will get the displacement and then the third equation of motion. So, displacement is what? Displacement S equal to what? Area of trapezium, what it is? AO DB, right? So, AO DB. So, what is the equation of area of trapezium? We have studied, no? Half D1 plus D2 into height. So, D1 and D2 are a parallel side. So, what? Sum of the, what is that? Sum of the parallel side, sum of parallel sides by 2 into height. That is D1, D2 by 2 into height. This is the area of the trapezium. So, what is D1 and D2 here? D1 is what? This is a parallel sides, no? So, D1 is U and D2 is what? V, right? So, what is D1? U into, sorry, U plus, okay, it is plus sum, okay, U plus V by 2 into height. How much is the height here? Height is This is the height, no? Height is t. T. So it is u plus v by 2 into t. So see our equation. Equation is 2as v square minus u square. Here t is not there, right? So t we have to substitute. So t, what is t? Similarly, using the acceleration, we can find a is equal to v minus u by t. So at is equal to, sorry, at, so t is what? V minus u by a. So we have to substitute here. So this is what? V plus u by 2 into v minus u by a. So it will be what? V plus u into v minus u, v square minus u square by 2a. This is our displacement. So 2as equal to v square minus u square. This is our third equation of motion. So what we did? We have to find the displacement. Displacement is equal to what? Area under the slope. That is area of the trapezium. Here, instead of finding the area of triangle and adding it to the area of the rectangle, we directly found the area of the trapezium. How? Area of trapezium is sum of the parallel sides by 2 into height. So d1 plus d2 by 2 into height. So what is d1? U plus v by 2 into t. That is, instead of t, we have substituted what? Using the acceleration equation, v minus u by a. So v plus u by 2 into v minus u by a, we got 2as equal to v square minus u square. So these are the graphical derivations of the equations of motion. So go through the videos clearly, and so that you will get an idea, and you can easily solve all the numericals related to the our chapter. Okay.